Okay, in this video we will talk about actual and theoretical yield. From the word itself it is clear actual yield means how much actually we are getting through the experiment, and theoretical yield means how much are we expecting. We can calculate that by using the balanced chemical equation. Then we will use actual and theoretical yield to calculate percent yield. The formula we use to find the percent yield is we have to use both actual and theoretical yield. So percent yield equal actual yield divided by theoretical yield multiplied by 100. So for example, if we have a theoretical yield of 10 grams and actual yield of 8 grams, we can plug in the formula percent yield equal 8 over 10 times 100, that will be 80% yield. So that was a direct question. Now here we have a balanced chemical equation and it is asking the theoretical yield of barium sulfate is 58.35 grams. If 44.34 grams of barium sulfate are produced from the reaction shown above, what is the percentage yield of barium sulfate? So we have the theoretical yield 58.35 and the actual yield is 44.34, and then we can substitute in the formula actual divided by theoretical times 100. That means we will have 44.34 divided by 58.35, we will have 75.99. And now let's see little more advanced level question, that is solid copper 1 sulfide reacts with oxygen gas to form copper 1 oxide and sulfur dioxide gas. How many grams of copper 1 oxide will be formed from the reaction of 75 grams of copper 1 sulfide and 21.5 grams of oxygen? If 55.8 grams of copper 1 oxide are produced, what is the percentage yield? So two questions here. So first what we will do is, since we have the word reaction given, we have to write the symbol equation first and we have to balance it. So copper 1 sulfide, so copper 1 sulfide is Cu2S, sulfur is -2, copper is +1, so we will have Cu2S that reacts with oxygen, and this is solid, this is gas, and we will have copper oxide, that is solid, plus sulfur dioxide gas. And now when you balance it, we can see 2 and 2 and 2 here and 3 here. And now from the equation, so from the question we have 75.0 grams of copper 1 sulfide and 21.5 grams of oxygen, and it also says we have 55.8 grams are produced, that is copper oxide are produced in the lab. That is going to be our actual yield. Okay, and now what we have to do is, since we have the information for both reactants, we have to find which one is the limiting reagent. So the limiting reagent I'm going to find for Cu2S, that's a reactant, and I will see how much Cu2O will form. Okay. For that one, I will start with what is given. So I have 75 grams of Cu2S and divide by 1, and I will convert that mass into moles. So we know in 1 mole of Cu2S we have 159.152 grams of Cu2S. So first I have to convert it into moles, and then I can convert that moles to the ratio of moles in the equation. That's the mole ratio between copper 1 sulfide and copper 1 oxide is 2 moles of copper 1 sulfide. The mole ratio is 2 moles of copper 1 oxide. So how much is that going to be? The grams of copper 1 sulfide, grams of copper 1 sulfide cancels, moles of copper 1 sulfide, moles of copper 1 sulfide cancels, and we will have moles of copper 1 oxide. So we can have the numbers from the numerator 75 times 2 moles of copper 1 oxide divided by 159.152 times 2. So 2 we can cancel, and 75 divided by 159.152 equals 0.47 moles of copper 1 oxide. And then we will see the other reactant oxygen, how much copper oxide it will produce. Okay, so for that one I have 21.5 grams of oxygen given divided by 1, and I can convert that one into moles. So we know in 1 mole of oxygen, the molar mass of oxygen is going to be 31.98 grams of oxygen, right? And then that moles of oxygen, I will compare the stoichiometric relation, the mole ratio in the balanced chemical equation. So 3 moles of oxygen, 2 moles of copper 1 oxide. Now I can cancel grams of oxygen, moles of oxygen, moles of oxygen. I will have moles of copper 1 oxide. So I have the numbers that equal 21.5 times 2 moles of copper 1 oxide divided by 31.98 times 3 in the denominator, that equal 43 in the numerator, 95.94 in the denominator, that equals 0.45 moles of copper 1 oxide. So which one is the lowest number of moles here is 0.45 moles of copper oxide. So we got that one using oxygen. So oxygen is the limiting reagent. Okay, and then we can find the second part, that is, okay, they're asking the mass of copper 1 oxide. So mass of copper 1 oxide equal mass of copper 1 oxide equal moles of copper 1 oxide times molar mass of copper 1 oxide. So that equals now we can say that 0.45 moles of copper 1 oxide equal in 1 mole of copper 1 oxide we have 143.09 grams of copper 1 oxide, that equals 64.39 grams of copper 1 oxide. And now we can find the percentage yield. So the percentage yield equal actual yield divided by theoretical yield times 100. So that equal 55.8 divided by 64.39 times 100. So that will be 86.65%. Alright, so now we can see the cross multiplication method. So first we can write the equation. So that is 2C2S plus 3O2 gives you 2Cu2O plus 2SO2. And then we have 75 grams of copper 1 sulfide. So I will write 75 under Cu2S. And we have 21.5 grams of oxygen. So I will write 21.5 grams under oxygen. And now first I will go with the copper 1 sulfide, and I will see how much copper 1 oxide will form. So I will find the number of moles by dividing with the molar mass of copper 1 sulfide, and I will get 0.47 moles. So now I can see the mole ratio, that is 0.47 moles will give how much copper 1 oxide. So I know from the balanced equation 2 moles, because here too 2 moles of copper 1 sulfide will give me 2 moles of copper 1 oxide, 1 to 1 ratio, correct? So how many moles of copper oxide will form from 0.47 moles is the same number of moles. So that means I will have 0.47 moles. Okay, so that's what going to be the number of moles of copper 1 oxide from copper 1 sulfide. And now I will see from oxygen how many moles will form. So then 21.5 is the mass of oxygen divided by the molar mass of oxygen is 31.98, that equal 0.67 moles I'm getting. And now from the balanced equation I have 3 moles of oxygen, and that gives 2 moles of copper 1 oxide. Okay, so how many moles will form from 0.69? 0.69, how many moles? So what I will do, just cross multiply, right? So the number is 0.67 times 2 divided by 3, that will give me 0.45 moles of copper 1 oxide. So when you compare this one, that is from copper 1 sulfide, and compare the moles formed from oxygen, the number of moles of copper 1 oxide formed from oxygen is less than number of moles of copper 1 oxide formed from copper 1 sulfide. So this oxygen is the limiting reagent. To find the mass of copper 1 oxide formed, we will just multiply the number of moles with the molar mass. So number of moles we have to take for the limiting reagent now. So because that decides how much product it will form. So 0.45 times the molar mass of copper 1 oxide is 143.09, that equals 64.39, that is grams of copper 1 oxide formed or calculated. Okay, and then we can calculate percentage yield. Actual yield divided by theoretical yield times 100, that equals 55.8 divided by 64.39, that equals 86.65%.